Hello everyone, you're welcome to this class. So in this class, we want to look at trigonometric ratios. And we've looked at some aspects of trigonometric ratios before in our previous video. But for the purpose of this video, we want to look at two things. The first one is a reciprocal of the basic ratios we have looked at before. And after looking at that, then we now go into the special angles, trigonometric ratios of special angles. That is angle 45 degrees, angle 30 degrees, and angle 60 degrees. We're going to look at their ratios as well. So without much ado, let's get into the business. All right, the word reciprocal. Anytime you hear the word reciprocal, reciprocal means 1 divided by. But as a reciprocal of 2, reciprocal of 2 is talking about 1 over 2. But you ask what's reciprocal of 1 over 2, just the reverse of it. We change it, that will be what? 2. All right. So that is what refers to as reciprocal. All right. So the basic ratio, three basic ratios we talked about the sine, sine, uh, cosine, that is cos, and tan, which is tangent. All right. So we want to find their reciprocal. So which means if I should ask reciprocal of sine, which means I'm saying 1 over sine. So the first one is what? 1 over sine. 1 over sine. So which means reciprocal of what? Sine. So that means reciprocal of sine, the meaning of this, we want to call this is what we call cosecant. What do I call it? Cosecant. Cosecant. Which is in short form, we call it cosec. Cosec. So this might be a little bit confusing. By the time we look at the three of them, we then look at how you can determine which one is reciprocal of sine, which one is reciprocal of cos, which one is reciprocal of tan, and so on and so forth. Then the second one is reciprocal of cos, which is 1 over cos, cosine. All right, and that gives us secant. That gives us what? Secant. So that is secant. Secant, which is in short form sec. In short form sec. All right, and the third one is 1 over tangent. 1 over what? Tangent. And that is going to give us cotangent. Cotangent, which is called cot. Which is called cot. Now, this is the shortcut that I want you to apply while determining it. Now, under cosec, the third letter from the left here is S, while the third letter from sec is C, while the third letter from here is T. So S is for sine, right? YC is for cos, and YT is for what? Is for tan. So from here, you should be able to determine, okay, sec is the reciprocal of what? Cosine. Cot is the reciprocal of what? Tan. While cosec is the reciprocal of what? Sine. I hope that is very clear. Now, let's now go into the details of it. How do we now apply this? So how do we apply this? It's very simple. So to apply this for sine, so we're making use of right angle triangle. So if you have your right angle triangle here, this right angle triangle, as you can see here, this is a right angle. All right, let's call this one A, this one B, and this one C. So the side that is facing A will be small letter A, the side facing B will be small letter B, and the side facing C will be small letter C. Don't forget that the side that is facing the right angle is the hypotenuse. We've explained that in details before. While the side facing the angle we're looking at is this theta. So this side is called the opposite, while the other side is the what? Is the adjacent. I hope this is very clear. So let me use another color. This is adjacent, this hypotenuse, this is the opposite. I hope this is clear. Let's use this is C, this is A, and this is B. I hope I'm making sense. Now, for us to now apply this, let's divide this. So we have, go back to this, or let's use black right now. So for the cosec, for the cosec. So don't forget, what do I call cosec? You look at it, the third letter here, which is sec. So that is the reciprocal of what? Sine, which is 1 over sine. This one is what? 1 over sine. 1 over what? Over sine. And the sine, so sine is, that is 1 over, so sine is so, which is opposite. We have explained this, over hypotenuse. All right? So that means this one will give us hypotenuse over what? Over opposite. And this will give us, what is hypotenuse here? That is C. And what is the opposite here? That is A. That is C over A. I hope this is clear. Now, for the second one, which is secant. All right, which is secant. So for the second, which is secant, which is, you can see the third letter here is C, which is cos. That is 1 over cos. So, and the cos is car, adjacent over hypotenuse. That is adjacent over hypotenuse. And that means the reciprocal we interchange, that was going to be hypotenuse divided by adjacent. So from what we have there, so from the diagram, hypotenuse is TC, all right? And the adjacent is what? B, that is C over B. I hope I'm making sense. Right. So the last one, which is cot. So that is 1 over tan. So that means the cot is 1 over, the cot which is toi, that is opposite over adjacent. I hope I'm making sense. So that means adjacent divided by opposite. All right. So adjacent here is B, while the opposite is what? Is A. So that is, these are the reciprocals of the 3 basic ratios of trigonometry. I hope this is very clear. So that is that on this. So you must make sure you understand this. We are still going to make use of this in the nearest future, but not now. So I just need to let you know about this. So the second objective we have is the ratio of special angles. So that is, we're looking at angle 45 degrees. But we're also looking at angle 30 degrees and the likes. So by the time we look at this, so the special angles here, so let's start with the first one, which is 45 degrees, angle 45 degrees. So let's start with special angle 45 degrees. So we're going to make use of, we are still making use of right angle triangle. So let's have this, we're going to make use of isosceles triangle. So isosceles right angle triangle. So this is it here. So this is the right angle here. All right. This side and this side are equal. So that is isosceles, right? Now, so the rule is that this side is 1 unit and this side is also what? 1 unit. So we need to find the hypotenuse. So we need to find what? The hypotenuse. So we want to get the 3 basic ratios of 45 degrees. So that is cos 40, sine 45, tan 45, and cos 45. I hope I'm making sense. So we want to get the value of sine 45, we want to get the value of cos 45, and the values of what? Tan 45. So that is the purpose of this. So, and we are going to look at their application, how examiners set questions on this. So we're going to see them and we'll see how we're going to apply them to solve problems. You know, I said something earlier on that there are some examiners, they'll ask you to leave your answer in short form. That's the purpose of this. So without understanding these concepts, you will not be able to present your answer in short form And if it's objective, you don't see answer there. So that's a big problem. So that is what we want to look at. Then let's continue from where we stop. So from this now, so having known the value of this, so since this one is 90 degree, and the remaining two angles are base angles of an isosceles triangle. So that's one thing you need to know. The angles that are facing the two opposite sides that are equal. The angle that are opposite the two sides that are equal are the base angles of an isosceles triangle. So that means that this angle here, this angle is equal to this angle. And since this is 90, so we have 90 left because sum of angles in a triangle is 180 degrees. So because of that, so 180 degrees minus 90 degrees, so that gives us 90 degrees. So you divide 90 degrees into 2, so this will give us for 45 degrees, and this also be what 45 degrees. So in that case, so we are considering 45 degrees, 45 degrees. So which we're going to have two opposites, two adjacent. That's what it means. I hope am I making sense with you? So why are we having two opposite and two adjacent? Because the angles we are considering, which is angle 45 degrees, we have it here, we also have it here. So which means we are looking at the first one here. So we are looking at this here, this one here. So this will be the opposite, all right? So this is going to be the what? The opposite, all right? This will be the opposite. And if you are considering this, so this is going to be the opposite. Are you with me? So you say the same thing. It was the opposite and adjacent. So it's the same thing here, right? So that means this will also be adjacent as well. And this also be what? Adjacent as well. I hope I'm making sense. So now we've known the value of the opposite and the adjacent to be what? 1. So this means hypotenuse. So hypotenuse, if you apply the Pythagoras theorem to this, if you apply Pythagoras theorem to this, let me divide this into 3. So if you apply Pythagoras theorem, using Pythagoras theorem, all right, using Pythagoras theorem rule, so which says hypotenuse squared equals to opposite square plus what? Adjacent square. So in this case, hypotenuse, which is this, which is here, let's call it x, that is x squared. Then the opposite, which is 1 squared, adjacent is also 1 squared. So that is x squared equals to what? 1 squared is 1, 1 squared is also 1. So that is 1 plus 1, that is x squared equals to what? 2. I hope I'm making sense. So that means x equals to square root of what? 2. So meaning that the hypotenuse here will be equals to what? Root 2. So that is where we're going. So we know the 3 sides now. So the next thing now to apply. So what is sine 45? What is cos 45? What is sine tan 45? So in that case, sine 45 degrees, all right? Sine 45 degrees now. Sine 45 degrees. So sine, which is so. Sine, which is what? Which is so. Sine is so. Which means sine theta equals to opposite over hypotenuse. So in this case, what is our opposite? Is 1. And what is our hypotenuse? Is root 2. That is square root of 2. But the funniest thing here is that we can't leave our answer to leave denominator to be in short form. So what we're going to do here, we're going to rationalize that we multiply this by root 2 divided by what? Root 2. It's just that we are multiplying it by itself. This is 1. So root 2, we cancel root 2, is still the same thing. So in this case, what we're going to have here is root 2, right? So square root of 2 times square root of 2, that is square root of 4. Square root of 4 is what? Is 2. So that means sine 45 is what? Square root 2 over what? Over 2. I hope this is very clear. I hope I'm making sense. All right. If that is the case, let's move on. Now, the next is cos 45 degrees. Cos 45 degrees. So cos 45 degrees, which is car. So this one is talking about car. So which is adjacent over hypotenuse. What is the adjacent in this case? Adjacent is still the same thing as 1. And the hypotenuse is, I'm coming. So let me change this. So to red. So this is That is 1 over root 2, which is the same thing as root 2 over 2. So what we are saying in essence here is that sine 45 degrees equals to cos 45 degrees. You can do me a favor, just go through your calculator and just punch sine 45 degrees and see what you're going to get. Then go to the same thing again and punch cos 45 degrees and see what you're going to get. So you see that we're going to get the same value. So if you, for example, have it just cos 45 degrees. So cos 45 degrees, 45 degrees, then cos. So you see what you're going to get. You're going to get 0.7071. Then if you go through your four-figure table, you get the same thing. So 45 degrees, and let's want sine. So go to sine 45 degrees as well. You get the same value, 0.7071. So that is that. We proved that. I hope that is very clear to you. So that is that on that. Then the next is the last part, which is toi. Toi. All right, and that has to do with tan 45 degrees. We're still going to come back to this, and that is toi. Toi means opposite over adjacent. The opposite is 1, the adjacent is 1, which means tan 45 is what? Is 1. 1 divided by 1 is 1. So you can see this now. So that means if you ask to leave your answer in short form, this is what you're expected to do. And the funny thing is that you have a lot of formula that you want to memorize. So you can, if it's possible for you, you can memorize all this. All this, you can memorize them. But if you can't memorize them, that is the basis I've given you today in this video. Quickly recap. There's no for you to cram anything here. You're not memorizing anything. Just look at the diagram, picture it in your head, and start putting everything down. Hope this is very clear. So the next one is sine 30 degrees and 60 degrees. So we're going to make use of another type of triangles. So here we make use of isosceles triangle. So the next one is we make use of equilateral triangle. So we're going to draw an equilateral triangle now. So that will help us to, let's erase this. So let me pick the red pen. I'm going to use this. All right, so we have this now. So we have this. So this line is equal to this line, is equal to this line. And in an equilateral triangle, all the sides are equal. So also all the angles are also what? Equal. So in that case, that means when you divide sum of angles in a triangle, you divide sum of angles in a triangle, sum of angles in a triangle is 180 degrees. Now, if you now divide 180 degrees, since all the three sides are equal, so it means we're going to divide 180 by 3, right? So that means each angle will give us what? 60 degrees. So that means each of these angles that we're seeing here is 60 degrees. I hope I'm making sense. So that is why this will be this will be 60 degrees, and this will be also what? 60 degrees, and this is what? 60 degrees. But the most funniest thing here is that this is not a right angle triangle. This cannot be used on SOHCAHTOA, but we can still work around it. How? So we're going to bisect this 60 degrees into 2. So we bisect it, we divide it by drawing a line here. So this line that is drawn here has divided this 60 degree, right, into 2. So this 60 degree has changed from this one would then be what? 30 degrees, and this also be what? 30 degrees. And this is the right angle here. This also another right angle here. So which means we can come up to this here. So I'm only bringing out this. This is 30 degrees. And this is what? 60 degrees. So now that is that on that. So we are not done yet. So let me divide this as well into 3 to help us out so that we'll not be going back and forth. All right. So for this now, what we're going to do here is because the sides are equal. So this is 2 units, this also 2 units, and this also what? This will then become, because this line are divided it into 2, this will become what? 1 unit, 1 unit. It now remains this vertical height here. Am I with you? This height, the height of this triangle. So that means this is 2 here, and this is 1 here, and we're looking for this. So we can as well apply Pythagoras rule to solve this. So this is the hypotenuse here, this hypotenuse here. So if we are considering here, let's have this to be adjacent. I'm considering 60 degree, and this is going to be what? Opposite. If I'm considering 30 degrees, sorry. So this is the opposite, this is the adjacent. So still the same thing, we just want to get the line. That's what we want to get. So we'll still come back to how to apply that. Now, so having done that, so the next thing is for us to now use Pythagoras theorem. So which says hypotenuse squared equals to opposite squared plus what? Adjacent squared. So hypotenuse here is what? 2 squared, all right? Opposite here is 1 squared, all right? And then adjacent is called x squared, all right? So this means that 2 squared will give us 4 equals to 1 plus x squared. So that means x squared equals to 4 minus 1. That means x squared equals to what? 3. Then x equals to what? Square root of what? 3. So which means this is what? Square root of what? 3. That is where we're going. So now the next stage is now for us to now apply this. How do we now apply this to bring out the short form of sine 30 degrees, sine 60 degrees, cos 30 degrees, cos 60 degrees, tan 30 degrees, tan 40 degrees, 60 degrees. So let's look at how to this. Let me duplicate this. All right. So in the next, what we're going to do now is let's start with 30 degrees first. So 30 degrees. To start with 30 degrees now, so I'm going to make use of, we're going to use another, let me copy this here so that it will not be confusing. So that is what we're going to be looking at. This is 30 degrees. All right. So this is 2, this is 1, and this is root 3. So this is the opposite here. This is the opposite, this is the hypotenuse, and this is the what? Adjacent. All right. So let's now start with the first one. Let's start with the first one, and that is sine 30 degrees. Sine 30 degrees. For sine 30 degrees, so sine, which is so, don't forget, sine is so, which is opposite over hypotenuse. So in this case, what is the opposite? That is 1. 1 is the opposite here, and the hypotenuse is 2. So that means sine 30 degrees is 1 over 2. If you check your calculator, that's when to get that 0.5, right? So the next is cos 30 degree. We are considering 30 degrees here. So we're looking at 30 degrees. So cos 30 degrees. So for cos 30 degrees, so that is car, all right? That is car. That is adjacent over hypotenuse. What is the adjacent here? Root 3 over hypotenuse, that is 2. So which means anytime you're asked to find cos 30 degrees, this is the short form of it, root 3 over 2. Then the last one, which is toi. The last one, which is toi, that means tan 30 degrees. Tan 30 degrees. So this will give us tan 30 degrees will then be toi. that is opposite. What is the opposite in this case? The opposite here is 1, and the adjacent here is root 3. So we can't leave it this way. So we have to rationalize. That is 1 over root 3, right? Multiplied by 1 over root 3 over root 3. All right, so that is root 3 all over root 3 times 3 is 3. So therefore, this is root 3 over what? 3. So tan 30 degrees is root 3 over 3. How this is very clear to you. So the next is to look at 60 degrees. So let's look at 60 degrees in the next slide. So for 60 degrees, we're going to do the same thing that I did here. I'm going to draw another, for 60 degrees now. So I'm going to redraw this shape here. So we have 60 degrees here. All right. So this is root 3 here. This is 2 here. This is 1 here. So I'm concentrating 60 degrees. So this will then become the opposite. This remains as hypotenuse, while this is the adjacent. So let's now go into sine 60 degrees. Sine 60 degrees. Let me close this. I'm still use sine 60 degrees, which is so. Which is so. All right. So which is so. Sine 60 degree, which is so, right? So that means I'm going to have opposite over hypotenuse. What is the opposite here? Root 3 over hypotenuse, that is 2. I hope that is very clear. That is true. Then we move to the next one. So which is cos 60 degree. So a student might ask, why can't we do what we did here? Why can't we do what we did here in this case? We can't do that because what we have here at the denominator here is a number, is a rational number. It's natural number, it's not a rational number, which is root 3. I hope you understand the rational numbers we discussed about. Check one of the videos there. If you understand it better, I think we've discussed that previously. So we are going to leave it like that. So, but when you have sort at denominator, you have to rationalize it in order for you to get the right answer. I hope that is very clear. Okay. Then cos, which is car. So car, which means adjacent over hypotenuse. So adjacent in this case is 1, and the hypotenuse is what? 2. So you can see now that sine 30 degrees, this here, sine 30 degree, all right, is the same thing as cos 60 degree. The same thing as what? Cos 60 degrees, as you can see now. So we're still going to bring everything together before we end. So the next one is tan 60 degrees. Tan 60 degrees. So for tan 60 degrees, that is 2. So that is 2. So this is 2. All right. So for 2, that is opposite over adjacent. What is the opposite here? Root 3 over adjacent, that is 1. So which means tan 60 degrees is simply root 3. I hope this is very clear. Now what we're going to do now is that we're going to combine everything together in a table and see what we can come up with this. So let's have a table here. I'm going to have table. All right, so we're going to have it here like this. So we have this. So we're going to have, let's put sine here, cos here, and the tan here. All right. So we're going to put the angles. So we'll put these angles here at the top here. So we're going to have 45 degrees here. 45 degrees here. We have 30 degrees here and 60 degrees here. So we now go to the table one by one. So let's fill them. So for table, for first one, sine 45 degrees is root 2 over 2. So sine 45 degrees is root 2 over 2. All right. Then cos 45 degree is still the same thing, root 2 over 2. That is root 2 over 2. And a tan 45 degrees, tan 45 degrees is 1. So that is 1. We put 1 there. Then we go to the next one, 30 degree. Sine 30 degrees is 1 over 2. That's 1 over 2. 1 over 2. All right. Then cos 30 degree is root 3 over 2. Root 3 over 2. Root 3 over 2. And a tan 30 degrees is root 3 over 3. Root 3 over 3. So that is root 3 over 3. Root 3 over 3. Then for 60 degrees, sine 60 degrees is root 3 over 2. Sine 60 degrees is root 3 over 2. And cos 60 degrees is 1 over 2. Cos 60 degree is what? 1 over 2. 1 over 2. And then the last one, which is tan 60 degree, is root 3. Simply root 3. So this is a graphical overview of everything. So let's now compare the one that are equal. So I've seen about 2. So this, don't let me use this. This is not clear. Okay. So let's pick this 1 over 2. That is sine 30 degree is equal to what? Cos 60 degrees. So we can put it here. So let's write it here. Sine 30 degrees equals to cos 60 degrees, and that is what? 1 over 2. So another one that is the same is root 3, this root 3 here, and this root 3 here. So you can see it's root 3 and root 3. So that is the same thing. So that is sine, just the opposite of it. Sine 60 degrees. Sine 60 degrees equals to what? Cos 30 degrees. And that is what? Root 3 over 2. You can just the opposite of it. And the last one we have there is this. Root 2 and what? Root 2 here. So that means this one is sine 45 degrees. Sine 45 degrees equals to what? Cos 45 degrees. And that is what? Root 2 over what? Over 2. Root 2 over 2. Root 2 over 2. I hope this is very clear. All right. So as you can see, so you've seen the main overview of everything here. So the next is now to look at the application. How do we apply this? So this video is very long now. I'll pause here. So in the next video, we're going to look at questions on this, how to apply what we have learned, and see how examiners set questions on this. I hope you find this video useful and helpful. So we're going to meet in the next video. Bye for now.